In this chapter 5, section 2, we're going to deal with congruent polygons. Most of what we're going to be talking about are triangles, but these rules and the things we're going to talk about refer to any shape of any type of congruent polygon. It could be a pentagon, it could be a hexagon, it could be an octagon, a quadrilateral. Most of what we're going to talk about, however, is going to be a triangle, are going to be triangles. Okay, so when we get here to congruent figures, we want to refresh our memory as to what we mean when we say congruent, okay? And when we're talking about congruent, we're talking about two figures that have the same size and the same shape. So that means they have the same number of sides, right? They have the same appearance. Their segments, the sides of those shapes, are going to be congruent to each other, okay? To the in the two shapes, and I'll talk about that. They're going to have angles that are congruent to each other. When you talk about what that might look like on paper, it's like if you went into Microsoft Word, or you went into your PowerPoints or your keynotes or your pages, and you copied a polygon and then you pasted it. When you copy and paste, it's always the same orientation, the same size, the same shape throughout. And then you kind of adjust it after, you might stretch it or whatever, but the basic copy and paste is equal segments. So what happens is when we do that and we copy and paste it, we're going to have two shapes, two distinct shapes. And what's going to happen is those shapes are going to have corresponding parts on one that correspond or match with parts on the other figure. And we're going to identify those oftentimes by, for example, tick marks. Notice angle A here, right? We've got angle A, and angle A has one tick mark, and it corresponds with angle F. Okay, so I might write down angle A is congruent to angle F. Not only does it correspond, but in congruent figures, those corresponding parts are congruent themselves. So A and F are going to be equal angles. I keep going and I identify angle B. And angle B has two tick marks, and it matches with E, which also has two tick marks. So angle B is corresponding with angle E, and therefore they're congruent. And I keep going and I keep doing the same thing. Angle C, notice it has three tick marks. It corresponds with angle D. And so I can write over here, angle C corresponds and is therefore congruent with angle D. And not only can I do that for my angles, but I can do it for my sides. Notice, for example, here, side AB has one tick mark. Well, that matches side FE. And so I could come over here and say segment AB corresponds and is congruent to FE. I can do the same thing for BC. It has three tick marks, and it matches with ED, which also has three tick marks. So I could say segment BC is congruent to segment ED. And I could do, lastly, I could do that for the bottom side as well. AC has two tick marks. It matches with FD, which also has two tick marks. And when I say matches, I mean corresponds. And so again, I can say that segment AC is congruent to segment FD. Okay, so once I know what go together, I can then start to figure out what things are equal to. Now, if I wanted to say that these two triangles or shapes are congruent to each other, I could say, for example, that triangle ABC is congruent to... Now, the issue here is I have to be very careful. It's congruent to the triangle, but I have to name it with the parts that match. Like ABC is in alphabetical order. You would think you could say, well, DEF. But I can't do that because D doesn't go with A. Notice that D goes with C. And so I have to be very careful when I name it to put the letters in the correct order. So again, since A goes with F, then I have to name it that way. The second letter here is B, and B goes with E. And the third letter is C, and C goes with D. And so triangle ABC is congruent to triangle FED. And notice, even if I didn't have a drawing, if I just told you these two triangles were congruent, without the drawing, you would know what go together. Because if A is first, then A goes with F. If B is second, then B goes with E because it's second. C's third, C goes with D because it's third. And the same goes for the line segments. For example, I can say, I can come over here and say, well, line AB. Well, that goes with FE. Notice they're first and second. I could say BC goes with ED because they're second and third. Okay, I can even say A and C go with F and D because they're first and last. So again, reading the order of the letters and what matches and corresponds is a big important step here. There's a theorem here, third angles theorem. This one's kind of obvious. It says if two angles of one triangle are congruent to two angles of another triangle, then the third angles of those triangles are also congruent. And so it may not seem super obvious when it's read like that, but let's actually write it out. Like, notice in these two triangles, angle B and E are congruent. So let's give them a value. Let's say B is 90 and E is 90. And then A and D are congruent. Well, let's say A is 30 and D is 30 because they're congruent. Well, together, 30 and 90 add up to 120, which we all know then that means that C has to be 60. Well, same here. If these add up to 120, then F also has to be 60. So mathematically, I can prove to you that C and F have to be congruent. The third angles in this thing have to be congruent. But the theorem tells us without having to use numbers, we just know that the third angles are congruent. In this slide, we're just going to refresh your memory on some properties that we utilized back when we did algebra, and then we utilized it again when we did angles and side lengths. If you remember the reflexive property, we said that any angle or side length equals itself. Well, same goes here. Any polygon that is congruent, or any polygon is always going to be congruent to itself. So triangle ABC is going to be congruent to triangle ABC. It is congruent to itself. Easy. The symmetric property. Remember the symmetric property told you that you could flip things across the congruent symbol and it would still be the same. So what this is saying is that if triangle ABC is congruent to DEF, then triangle DEF is congruent to ABC. So even though I flip it across the congruent symbol, it's still an acceptable thing to do. Okay, which again, that's simple for you guys. Just applying, just know that these reflexive, symmetric, and transitive properties can be used not only for angles, not only for side lengths, but for entire shapes. So the transitive property of congruent triangles basically says that, again, here we've got if triangle ABC is congruent to DEF, and DEF is congruent to JKL, then I can go straight from ABC and say that it's congruent to JKL, like we do here. And again, this is just the transitive property, and you're applying it to an actual entire shape like a triangle. So here we're going to do our sometimes, always, and never, and this is tough for some of you guys that might be a little bit impulsive. So you really have to stop and think about what we're saying here, okay? So, for example, an acute triangle is always, sometimes, or never congruent to an obtuse triangle. And this is going to be one of the few nevers here, okay? This is definitely a never, because remember that acute triangle, all three angles are acute. Well, in an obtuse triangle, one of the angles is going to be obtuse. So you're never going to have an acute triangle that has an angle equal to that obtuse triangle. And remember that congruent shapes, all the angles have a corresponding congruent angle in the other shape. So in other words, the three angles have to match the three angles of the other shape. Here, a polygon is always, sometimes, or never congruent to itself. Well, it's always congruent to itself. Okay, that's the reflexive property. A right triangle is always, sometimes, or never congruent to another right triangle. This is going to be sometimes, okay? Because, for example, I might have a right triangle, okay, like this, that's like a 45, 45, 90 triangle. I could have a right triangle that is like a 30, 60, and 90. So again, I might have another one that's like this, so they would match, or I might have one that's like this that doesn't match. And so again, sometimes they could be congruent and sometimes they won't. If triangle ABC is congruent to XYZ, triangle XYZ, then angle A is sometimes, always, or never congruent to Y. Well, let's look at it. Angle A is the first value, and so I know it corresponds with X. A and X are always going to be congruent. Can A be congruent to Y? Maybe. So that's going to be a sometimes. It doesn't have to be, but it could be. And then the last one is if triangle ABC is congruent to XYZ, then angle A is sometimes, always, or never congruent to X. And that's going to be an always, because again, notice they're corresponding. They're in that same spot. It's a corresponding angle, and so they're going to be congruent. Here we're getting ready to, now the fun begins where we're actually trying to solve a problem here. Notice they tell us that in the diagram, ABCD is congruent to FGHK. So notice the parts that go together. I'm going to write it out so that we have it. But I know, for example, that angle A is going to then be congruent to angle F. Angle B congruent to angle G. I've got angle C is congruent to angle H. And we have angle D is congruent to angle K. So now that I know the corresponding angles, right, I know how to kind of do the math here. So when I look and I see, well, there's a measurement, they're looking for something related to K, and I know that K and D go together. So I know that angle K, remember, I know that angle D is congruent to angle K. That means that 44 is going to be equal to 4x plus 2y. Now, if this was only one variable, I could solve it, but notice I have an x and a y, so I'm going to need to know x or y before I can do that. So what else am I given in this problem? Well, I notice that I'm given these side lengths. I know that they gave me the value of GF, and I know that GF, which is the first two here, right, FG or GF, corresponds with AB, which is this one, which is 9 inches. So again, I know that, side length AB is going to be congruent to side length FG. And so if AB equals 9, it's going to equal FG, which is 3x minus 6. So I can just kind of do the math here. I get 15 equals 3x, divide by 3, and I know that x equals 5 units. So x equals 5, which is good. Now I should be able to plug that in up here to find my y value, right? So I have here now, I go back to this equation, 44 equals 4x plus 2y. And I know again that x is 5 now. So I get 44 equals 20 plus 2y. I'll subtract 20 from both sides. I get 24 equals 2y, and if I divide by 2, I get 12 equals y. And so I have that y equals 12. And so that should be all that I need. I can always double check, plug my numbers in, and make sure that I'm doing the math correctly, but that's how we do this, and, take your time. Obviously, if you have one with 2 variables, it may not be the first one that you can solve. You may need to start with the single variables first. Here we've got Maggie took the piece of fabric, STUV, shown in the diagram, and cut it on the diagonal to make a scarf for her and her friend. Are the 2 pieces the same size and shape? Explain. Well, if you notice here, we're going to look at this. She started with a rectangle. Notice this is a rectangle. All 4 sides have your 90-degree angle. Well, if it's a rectangle, we know, the sides that go together, right? We know that these 2 sides are congruent to each other. We know this side is congruent to this side. And we know that this diagonal is really now, this line is part of both shapes, but we know that it has to equal itself because of the reflexive property. So these angles here, or these sides, we know that every side has a corresponding side that it's equal to. So based on sides, we're looking pretty good. The other thing is, what about the angles? Because remember, congruent shapes have to have the same angle measures. Well, I know that this diagonal here, angle 2 here, is going to equal angle 3 here. Now, there's a couple of reasons I know that, and I could even see these two lines. Remember, in this shape, these lines are going to be parallel to each other. And so 2 and 3 are alternate interior angles. So I know that they're going to be, the diagonal sort of represents a transversal. 2 and 3 are going to be equal to each other. And I know that angle 1 and angle 4 are going to be congruent. And so notice that my shapes, my two triangles, have the 3 angle measures that go together as well. 3 goes with 2, 1 goes with 4, and the 90 degrees goes with the other 90. And so, yes, these are going to be congruent, okay? And then lastly, we have an actual proof that we have to prove that these things are congruent or whatever they're asking us to prove, right? So let's kind of look at it. It says, given that SV is congruent to RV. So let's start with that. Segment SV is here, and it's congruent with RV. That's one of your givens. Segment TV is congruent with WV. So this segment here is congruent with this segment there. And then the third one says that ST up here is congruent to RW. Lastly, they tell us that angle T is congruent with angle W. This angle is congruent to this one. So remember that to prove that a triangle STV is congruent to triangle RVW, we must prove that that there's 3 pairs. Let me write it here. We have to prove that there's 3 pairs of corresponding angles that are congruent and 3 pairs of segments or sides that correspond and are congruent, okay? So I got to prove those 6 things, okay? So let's go to our statements. Let's go to our reasons. And if you notice, they sort of gave us 4 of these already in the givens. Notice in the given, we have the 3 sides being congruent and corresponding to each other. That was in the given. And I'll show you. It was ST is congruent to RW. It was TV is congruent to WV. And it was SV is congruent to RV. All of these have to do with the sides, and so I put them together in the given. The second one is they gave us one angle that was equal. They told us angle T was congruent to angle W, and that was also given. So obviously, to do this now, I'm going to need to prove these triangles are congruent, I'm going to need to prove that the other 2 angles are congruent. So the first one I'm going to go to is here. I know that this angle here, angle SVT, right, is congruent to angle RVW. Okay? And I know that because vertical angles congruence theorem, right? I think we call it that, right? I know that those are vertical angles, and so I know that this angle and this angle are now congruent. So now guess what? I have a second pair of angles. The last thing I know, right, is number 4, the next proof that I know that angle S is congruent to angle R. Now, how do I know S and R are congruent? Well, remember the theorem that we learned, the third angles theorem? Third angles theorem says if the other 2 angles are congruent, then the third one's congruent. Okay? And so to be at this point, this is really the end. When I get to 5, STV is congruent to, or triangle STV is congruent to triangle RWV. And I would just, I'm trying to see what statement, I mean, I guess definition of congruent polygons would just be the definition. Once I proved that all 6 things were congruent, the 3 sides, the one side they gave me, or the one angle they gave me, and then the other 2 angles, then I had everything I needed to prove that the triangles were congruent as well.